Hey everyone, I apologize. The last video got cut off abruptly, but I'm going to continue it in this next video. So we'll go back to where we stopped. So we were doing bases and we were trying to figure out these patterns. So as I was saying, so in base 3 you have digits 0, 1 and 2, right? So 2 is your last digits, just like 0 to 9 are in base 10, and 9 is your last digit before you move on to 10, right? So just like 9 plus 1 would give you 10 in base 10, in base 3 the last digit is 2. 2 plus 1 would give you 10 here, okay? And just like how 99 plus 1 gives us 100 in our base 10 system, we have 22 which acts as a 99 plus 1 which gives us 100 in base 3, right? And then you have 999 plus 1 which gives you 1000 in our base 10, and the same way 222 is the last digit, so 222 plus 1 gives you 1000 in base 3, okay? That completes page 7, and I'm moving on to page 11. So on page 11, we're here, place value, read aloud. You have a column called base, and then you have digits and you have words. Base, you have decimal, quaternary, ternary and binary, and here are your digits. You have 11 to the base 10, 11 to the base 4, 11 to the base 3, and you have 11 to the base 2, okay? And the words, I'm sorry, I shouldn't have said 11, right? I should have referred to the words. So the words are, you have 1 10 here and 1 1, right? So we know 10 plus 1 is 11. So we have 1 10 and 1 1. When you have a quaternary, we say 1 4 1 1. Then when you have a ternary, we say 1 3. This is third base. We see 1 3 and 1 1. And then for a binary, we say 1 2 1 1. Okay. All right, complete the table. This is your scientific notation, and then you go to a standard scientific notation, and then you have significant digits, okay? The scientific notation says 16.36 times 10 to the power 1, okay, or 10. So we know in multiplication, when you multiply decimals, we know, for example, if I have 2.1 times 10, when I'm multiplying a decimal which has one digit after the decimal point, and you multiply it by 10, just think of it as this 0 offsets this decimal point, or it moves it one space to the right. So your answer is 21. In other words, if you add 2.1 plus 2.1 plus 2.1 10 times, you'd get 21. Instead of doing that, the shortcut is you take this decimal point and you move it to the right when you multiply it by 10, okay? When you multiply the same thing by 100, what happens? You move this decimal point by how many zeros you are multiplying it by. You're multiplying it by 2 zeros, so you offset it by 2 places to the right. So 1 and another 2. So this would be 210. Okay. So when you multiply 2.1 by say 1000, right? Now you offset this decimal point by 3 places. So you put, this is 1 place because you have 3 zeros here. You're offsetting it by 3 places. So 1 digit, 2 digit and 3 digits. So I'm going to put a 0 and a 0. So now my answer is 2100, right? So that's this is the basic. You guys know this from your previous math studies, right? So now they're saying you have 16.36 times 10. You can also write this as, if I want to write this in a different way, okay, what I can do is I can write this as 1.636 times 10 squared, right? If I multiplied this by 10, what do I get? I get 163.6 because I'm offsetting this by 10, right? One digit. And if I multiply this by 100, what happens? I'm moving this decimal point 2 places. So I'm still getting 163.6, right? So you get that? So it's the same thing. It's just a different way of writing. So you would write the same thing, just move it one place to the left and then add another 0, okay? I hope you're catching on to that. So let's see the next one. It's